Hello, welcome to Maths with Jay. Last time we looked at the first part of this question, so we found x in terms of t, so let's write that down. And what we're going to be doing in this video is looking at part B. So we're being asked to find the maximum value of x, so we'll need to differentiate that with respect to t, and then we've got to justify that this is the maximum value, so we'll differentiate again and check out that we do get a negative value for our second derivative. Okay, so let's start on a new page. So differentiating, we're going to get minus 3 times minus 1, so 3e to the minus 3t minus e to the minus t. And remember that we're looking for a maximum value of x, so our first derivative will be 0. So we've got 3e to the minus 3t minus e to the minus t is 0. So that what we want to really do is just have the t in one place. So if we multiply everything by e to the 3t, that will work, won't it? So that we'll get 3 there, and then 3t minus t will be 2t, so that will be e to the 2t there, and that will be 0. So we've multiplied each term, both sides of the equation, by e to the power of 3t. And that will give us that e to the 2t is 3. So 2t is log 3. So that's the natural log of 3. And then t is going to be a half log 3, so halving both sides. So now we found the value of t that makes x a maximum, so now all we need to do is substitute that into our equation for x, and then that will give us what x is as a number. And we already know what we're expecting that to be because it's given in the question. So let's just give ourselves a bit more space, put this over to one side. So now we can substitute that value of t into x. So we get x is equal to minus e to the minus 3t, and t is a half log 3, and plus e to the minus t, so that's minus a half log 3. And remember that you know that e to the log a is equal to a, because log of a, well, that's log to base e, so e and log are inverse functions, so that's true. And then also e to the x log a is equal to a to the x. So that when we're looking at this, we can say that this is equal to minus 3 to the minus 3 over 2 plus 3 to the minus a half. Now it's probably easier if we write this without the negative powers, so we can think of the first number as minus 1 over, well, 3 to the 3 over 2 is 3 to the power of 1 and 3 to the power of a half, so that's 3 root 3, and the other one is simply 1 over root 3. And then if we multiply top and bottom of those fractions by root 3, then we're going to get minus root 3 over 9 for the first one, and root 3 over 3 for the second one. And remember, in the actual answer we're given, we know we're expecting the denominator to be 9, and in fact it's obvious that that's really what we need to do here, isn't it? So the first fraction we're leaving, and then multiply the second one top and bottom by 3, and so that's going to be 3 root 3 minus root 3. So let's just write that down for completeness to make it absolutely clear that we really do know how we're getting this answer. And so 3 root 3 minus root 3 is 2 root 3 over 9 meters as required. So now all we need to do is differentiate again. So we're going to find the second derivative of x and show that we do get a negative value when we substitute in the value of t. So let's give ourselves some more space to do that. So differentiating again, so remember this just means that we're working out d by dt of dx by dt. So let's just make it really obvious what we're doing. So we're differentiating this again. So that's going to be minus 3 times 3, so minus 9 e to the minus 3t. And then we've got plus e to the minus t. Now what we want to do next is to substitute in the value of t that makes the value of x a maximum. So remember that we know that t is a half log 3, but we also know that e to the power of 2t is 3. So let's just write down the important things that we're going to be using. We've got that t is a half log 3. Now it's not that much use to write down that 2t is a log 3, but what is useful is that e to the minus t is equal to 3e to the minus 3t, because 3e to the minus 3t minus e to the minus t is 0. So that means we could say that what this is equal to is minus 9e to the minus 3t plus 3e to the minus 3t, which is minus 6e to the minus 3t. Now e to the power of anything has to be positive, so at this stage we could actually say that this is negative, but really for completeness we really ought to work out what this is, shouldn't we? But all we really need to do is to look at what e to the minus 3t is. So it's e to the minus 3, and t is a half log 3. So that's going to be minus 6 times 3 to the power of minus 3 over 2. So that's minus 6 over 3 root 3. 6 over 3 is 2, so minus 2 over root 3. Or you could write that as minus 2 root 3 over 3 if you like, but the important thing is that that is negative, and that justifies that we have actually got a maximum value.